Have you ever noticed one laptop boots Windows in 5 seconds and another takes 2 minutes? Same Windows, same software. So what's the difference? The answer is storage. In this video, I'll explain how SSD works, why it is so fast, and the complete evolution from HDD to NVMe SSD in the simplest way possible. Storage is the place where your operating system, software, games, and files are permanently saved. When you shut down your computer, RAM is cleared, but storage keeps everything safe. Let's start with the old king, the hard disk drive, or HDD. Inside an HDD, there are metal plates spinning at very high speed and a tiny read/write head that physically moves to read data. Step by step. 1. Disk starts spinning. 2. Head moves to the correct location. 3. Data is read magnetically. 4. Data is sent to RAM and CPU. This means physical movement every single time you open a file. Imagine trying to read a book placed on a rotating fan. Slow, risky, and inefficient. Your hand must wait for the right page to come around, and if the fan speeds up or shakes, you lose your place. That's exactly how an HDD works. The disk keeps spinning, the head keeps moving, and your system keeps waiting. Now imagine the same book opened directly in your hands. You flip to any page instantly, with no waiting and no effort. That's SSD. No spinning, no delay, just instant access. HDD is slow because of mechanical problems. Spinning delay, head movement delay. One task at a time. Sensitive to vibration. That's why old computers feel laggy, especially when multiple apps are running. Now comes the game changer. SSD solid-state drive. SSD has no moving parts. It uses NAND flash memory, just like your smartphone. Inside SSD, NAND flash chips, controller, the brain, no motor, no head, no spinning. How SSD reads data. When the system asks for data, the SSD controller fetches it electronically, instantly. No waiting, no movement, just speed. HDD is like finding a song on a cassette tape. SSD is like tapping a song on Spotify. SSD is fast because it can read and write data in parallel. Main reasons: microsecond access time, parallel data lanes, smart controller, advanced algorithms. This is why Windows boots in seconds on SSD. SSD distributes writing evenly across all cells, so no single area gets damaged early. Like rotating car tires. SSD keeps hidden spare space to replace damaged cells and maintain performance. SSD cleans unused data blocks automatically in the background. Operating system tells SSD which data is deleted, so SSD prepares clean blocks in advance. First generation, IDE HDD. Very old, thick cables, extremely slow. Second generation, SATA HDD. Better cables, same mechanical limits. Speed, around 100 to 150 megabits per second. Third generation, SATA SSD. Same SATA cable, but flash memory inside. Speed, up to 550 megabits per second. Even this feels 10 times faster than HDD. Fourth generation, NVMe SSD, the monster. NVMe SSD connects directly to the CPU using PCIe lanes. Speed, Generation 3, approximately 3,500 megabits per second. Generation 4, approximately 7,000 megabits per second. Generation 5, 12,000 plus megabits per second. HDD is a bicycle, SATA SSD is a car, NVMe is a fighter jet. Windows boot time, HDD to 1 to 3 minutes, SATA SSD to 10 to 15 seconds, NVMe SSD to 5 to 7 seconds. NVMe removes bottlenecks and massively improves performance. People say SSD dies quickly. That's only half the truth. An SSD does not wear out by reading data. The real wear happens only when you write data. Every time data is written, the SSD must erase and reprogram tiny memory cells, and that process slowly consumes their lifespan. Reading data, on the other hand, causes almost zero wear. You can open files, boot Windows, and run applications millions of times without harming the SSD. This is why normal users almost never kill an SSD. It's heavy, continuous writing that matters. TBW, terabytes written. Most SSDs are rated for hundreds of terabytes of writes, far more than normal users need. SSD usually fails suddenly, without warning. That's why backup is not optional. It is mandatory. HDD is slow because it moves. SSD is fast because it thinks. NVMe is fastest because it talks directly to the CPU. If this video helped you understand SSD properly, hit the like button. Comment if you want the next video on Enterprise SSD, RAID with SSD, or choosing the best SSD for servers. And don't forget to subscribe for real, practical tech knowledge.